Okay, I don't actually have a lot to talk about with the PRs, so go quick. I did not see any new or updated ones this week. Um, just I think everybody's taking a little bit of a break after all the Quincy work that happened. But there, the one that did close was this tracing PR. I approved it last week. The new numbers looked really good that came out, so that has now merged. So that's really good. Otherwise, I have a bunch of stuff that I need to go through and figure out what to do with a bunch of PRs, old PRs. I still need to look at this CPT toothology perf testing thing. I don't know why it's apparently sometimes not giving results, but I don't know. It's there's a lot of glue code in all of this, so probably something to do with that. Um, let's see. TC Malloc, enabling TC Malloc with C star. That we have to decide what we're going to do about the ASAN errors that were cropping up with TC Malloc. I don't think it's our fault. We just have to decide if we care about them or if we're just going to kind of whitelist it. So, what else? This time-based adaptive near-fit algorithm, this is low priority, but I can at some point update that. See, we don't have cores atom. I was going to say this allowing the control of TC-malloc thread cache size with a Ceph configuration option. That's still actually, I think, a really good idea. But I don't know, not necessarily super high priority. Gabby, related to the thing we were just talking about, so in the Etherpad, there's this PR, which adds some OMAP benchmarking capabilities to the Google test suite, store test. But it adds a lot of extra stuff in store test, like it takes longer to run. But it was actually really useful when we were playing with it. This may help give an idea of what OMAP and RocksDB uh, overhead looks like how fast we can do that. It doesn't necessarily tell you about like performance while you're running this, but you could run this in another benchmark at the same time.
Are you saying there's a benchmark for um, snap removal
No, it's OMAP.
or OMAP? Okay. And snap mapper is using OMAP, right?
Yep.
Every snap object is represented by a duo of OMAPs, one from object ID to snaps and one from snap ID to objects.
Yep. And I think did we determine that iteration behavior was still a big deal?
We are not sure, but whatever is the actually, sorry, there is no iteration. The current code, what is doing iteration size of 2. So it's unlikely that iteration is a serious cost. But
Okay.
we hope to change it and then do each time, I don't know, maybe 100 of object each time. So iteration would become more of an issue. But another thing we think might be possible to do there is to change the data structures. At the moment, the way I understand it, Snap Mapper is a single global object holding all the Snap information. I think we should break it down by PGs.
Yes.
So every PG would have its own mapper. So if you remove a snap object, it's only going to affect you're going to remove the snap on every PG, but every PG is a standalone thing, so I don't see what kind of dependency would be between two PGs, but I might be missing something. And then if we would break it further and making every PG would have a table of snaps, and only there will have the object. So then when you remove it, it's going to be an object that nobody else is accessing, so you don't even need locks.
And
And
Gabby, that piece that you just described, I think, was the only thing really holding us back from doing like for PG sharding in Blue Store. There's other stuff, but not really important stuff. Like that was the thing that always came up as one of the reasons why we can't do like independent hashing across PGs PGs across shards, right? That you had this global snap mapper thing.
so I'm not sure why is the snap mapper a global object. I cannot see any benefit from holding everything together, and I could clearly see benefit for breaking this into multiple small objects. So, for example, you're not going to have lock collisions and such. And it's not that it's the same object. Sorry, no, logically it's one object, but since every PG is a standalone entity, why do we need to share data across PGs?
Josh, do you remember? Because I don't remember there ever being any real reason why it looks the way it does. But that's it's every time I've asked about it, it's always kind of been like, kind of a hand wavy. Don't really remember. We don't have Josh. So Gabby,
There is anything to do with maybe if you want to create a snap across multiple PGs, you could do it using a single lock, but I would expect that you'll be able to grab multiple locks and then do the same things. Maybe it was just because snap creation is a very short time from, if you look at the lifespan of a snap, which is access every time there's a write or if there's somebody trying to read. So that thing is going to be long-lived, but snap creation, it's really a fraction of a second. So we should not optimize for that case, and we should optimize for anything else. Snap removal, snap access, snap write, snap listing, and such. And by breaking into multiple PGs, I think we should be able to optimize the access.
Yeah, I'm trying to go back and look at the history of the Snap Mapper GitHub. Just looking at pull request and it works so well. So have you already done this, Gabby? Have you looked kind of at the Snap Mapper source history?
I didn't try to look at this.
Okay,
I
okay.
mean, I tried reading the online documentation, but it was extremely short.
I mean, like, I think this
So
is
the only
the
thing I could think about is somebody was trying to provide an easy mechanism to create a snap across multiple PGs because that's a single synchronization object. But I think that thing could be done even if you got multiple snap marker, one per PG. You could still synchronize the creation by grabbing multiple locks.
so in the chat window, I posted a link. I think this was the original commit of the Snap Mapper. back in 2013.
I think so.
Okay, so it was done by Saint Just, so we should really get him.
I don't know how similar this looks to the code we have now. I
Actually,
haven't.
it looks very similar.
Yeah, I suspected that this probably hadn't changed a whole lot.
Yeah, I mean, there is now more event tracing and such, and more sanity checks and more error handling. But actually, that's a cleaner piece of code because we don't handle all the corner cases.
So yeah, what this is appears to be the state that it came in, like what the original you know intent or thought was here.
But do we have? So here's the code, but where is the pull request or anything?
I don't know if there was one at this point. This was fairly early on. This may have come in just as a direct commit to the main uh, branch.
So there is. Where is the commit log? Planning something? I mean, is there no commit message?
Doesn't appear to be one that I see. Just a title. Things were a little more, less documented back then, I think. I wonder if there might have been something else in the tracker, or I don't know.
Oh, we should definitely get Sam. Otherwise, we just be guessing what he meant.
Yeah, yeah. I was hoping that maybe there would be a pull request associated with it. Maybe there was, and we just lost it over the years. I don't know. There were a couple times where I think we reorganized things, and maybe somehow some of that metadata was lost, if there was one. But in any event, so your proposal, Gabby, I mean, the gist of it is that you want to do the same thing with the snap mapper that you did with the allocation data, right?
Yeah, so there are three parts to the suggestion which could be done independent of each other. The first one, which I think is the most obvious, it's object node got duplication data, which a duplicated set of data, which could be used to recreate a snap mapper. So there is really no reason to make snap mapper protected by RocksDB. At the moment, anytime we update the snap state, meaning if we are writing to an object which is protected by snap or clone and we have to do copy on write, then we need to add new mapping object to SnapMapper from object ID to the Snap ID. If we also add another Snap version, we need to again edit this thing, and then there is a reverse mapping from the Snap ID to the object, and we need to add one more entry for this. So my understanding is that every time we add or delete an object touched by Snap, it's going to cost us 2 RocksDB accesses. And when the Snap is deleted, we tend to do the delete in burst. Right, so you could have thousands of objects. We need to delete them all, and every deletion is actually translated into 2 deletions. So there's a burst of tombstones creations. And that's one we suspect that might be one of the reason for RBD mirroring pain, because RBD mirroring is creating snap every 15 minutes, and then it's iterate over the snap to copy the data to the remote site. Once it's done, it's going to issue a command to delete the snap, which is going to take all the objects and remove them. But there's going to be a burst of tombstones, and RocksDB really doesn't like tombstone. And my suggestion was take SnapMapper out of RocksDB completely, keep it as an in-memory data structure like we have for the allocator. And when there is graceful shutdown, we could enumerate the SnapMapper and stage it into a single flat file. It's going to add a little bit of time to shut down process, but I think it's only going to be tens to hundreds of milliseconds. It's not going to ever reach 1 second. As I've seen with the allocation map, I think the worst case scenario, if huge map was taking half a second. So I think it's safe to say it's going to be no more than a few hundred of milliseconds on a very big system.
And right now the iteration that you mentioned when you iterate, and then is that before or after the deletion? Is it also iterating during deletion?
So deletion, you do an iteration, but for deletion, you just start the iteration, take the first 2 objects, and you are done. And then you're going to start another iteration. But if you do a copy, I would imagine you do another iteration. So in RBD mirroring, they probably have to iterate over the snap to know which object to copy to the remote site. So I expect that's the iteration you see. But so let's just deal with this later. I just want to first introduce the first concept.
Yeah, sure. Sorry, go ahead.
So the first concept saying we don't need RocksDB to give us protection for the snap mapper. At shutdown, it's going to be staged to a file. It's going to cost us hundreds of milliseconds in worst case scenario, no big deal. On startup, we're going to read it from the file into the memory object. And here we're actually going to save time because reading from a flat file is much faster than reading from RocksDB. My experience with the allocation map seems to indicate we could actually save maybe 1 second on a, again, big system. If it's small system, none of this matter. But if it's a big system, I've seen that reading the allocation from RocksDB can take a few seconds. Again, it's very big system, hundreds of millions of objects. Here with SnapMap, I don't think it's ever going to grow to hundreds of millions of objects. So probably whatever you do, it's not going to make any performance impact on shutdown or startup. But even if it does, we're going to slow down a bit in shutdown, but make up for this by a faster startup. So that's the easy thing. And we already have the code. Sorry, we have the entry point when we can safely destage the map because we know when RocksDB is disabled and when BlueStore is active, and there was a lot of race conditions at the time when we did the allocation. We needed to find a perfect position when RocksDB is inactive, but BlueStore is still active, but BlueStore is not moving stuff internally. So all this thing and all this pain we experience is going to benefit us now because we have the exact entry point to call for store and restore. So that thing should be relatively easy. It's essentially serialization of the object, doing a write to disk, and again, reading from the disk and populating the object. Should be very simple process. And this time it should be safe because we know what we're doing and when it should be safe to do that. So that's part one. Part two is, of course, what should be done in case of a disaster. Because RocksDB used to give us protection from disaster by using write-ahead logs and all the availability concept that you got from RocksDB. We're going to keep RocksDB. So in a disaster, we're going to lose the snap mapper. The same way we lost the allocation map in a disaster. And again, we could use the same mechanism. We can iterate over object node in RocksDB and recreate snap mapper from them. This is what we're doing for the allocation map. And that process is expensive, and on big system, it can take minutes. And again, big system means hundreds of millions, maybe billions of objects. But I think this time we're not going to add a lot of cost, extra cost, because we have to iterate over RocksDB object anyway. This thing we do for allocation map, and that was the biggest part of the cost. I think it was like 80 or 90% of what we do is the cost iteration over RocksDB. Everything else was relatively simple. So if anyway we iterate over RocksDB, process the object, recreating the snap map, I assume it's going to be a matter of few more seconds. Maybe it's going to add 10% time to the overall process. I don't even think it's going to be that expensive. So, and again, also, snap mapper tends to be much smaller than the allocation map. We don't have that many entities. In the allocation map, in worst case scenario, I was talking about billions of entities. I don't think snap mapper is holding billions of objects which have been affected by snaps. But even if that would be the case, I would expect that recovery time would be maybe 10% slower than it is now. So that's suggestion number one, which I expect it makes sense. And I ran it by Josh Dargin, and I got some feedback from Matan, and the feeling is that the object node have enough information to rebuild the data, because that's the real problem. How do you rebuild the snap mapper from the object node? And there was agreement that the information there is sufficient for rebuilding. That's project number one. Independent of this project, we suggested another project. Project number two, nothing to do with this project. I mean, they could be done one after another. We could choose just one of them, or we could choose them both. Oh, of course, you can choose. The second project is dealing with just the deletions. The first project is going to impact any access to Snap. The second one is only going to impact Snap deletions, which is a very common thing for RBD mirroring. Again, RBD mirroring, every 15 minutes, we generate a new Snap. We move it to the remote site, and then we delete it. The deletion that is done today, we iterate over snap mapper. We take each time two objects. I don't know why we chose this number two. But never mind, even that number is not utilized really, because for each entity, for each object from the two that we took, so the only thing we use the two is just to make the iteration more efficient, but really two is. Then for each object, we act as if this was a write, meaning we need to create a replication job and a pglog entry to represent the fact that we are going to delete the object node. So every object node that we're going to delete is going to generate a pglog, is going to do communication with the replicas, and it's going, of course, to go to RocksDB. So first thing, we go to RocksDB, we delete the object node from the snap. We also delete the two objects from the snap mapper, which if we do the first project, then that part is going to go away, make it cheaper. And we create a pglog entry to describe it. We send it as a replica. When we get all ACK, we delete the pglog. So the suggestion here is, why should we be doing a single object each time? The pglog that we generate to protect us could be utilized to describe a big list. The number we are thinking about maybe 100, but of course we could go 50, 200, I don't know, just find a good number. And then we're going to generate a pglog entry with the list of all the entries that we're going to delete. It's not a write. I think the problem is that we simply took the code we had for client write, because the client write, it's something we cannot anticipate. So we have to do one each time. At the time, I suggested that we would merge multiple host write into a single pglog entry for the benefit of decreasing the amount of pglog and tombstone. And there was some objection to this because it might change scheduling and such and ordering, and I don't know. So I didn't continue doing this. But in deletion, there is really no ordering because the snap is disabled. So there is no reason to do one object at a time. Take 100, create a pglog entry, remove them locally. Replica would remove the full list of 100 objects. You got all up, you remove the pglog entry. So the pglog pane is going to be amortized on maybe 100 objects. So in effect, it's actually going to mean that pglog going to cost us 1% of what it used to cost us. And of course, we're going to save TCP communication with the replicas, and we can do everything else somewhat faster. So that's project number 2. Anybody? Any comments, suggestions, corrections?
So for project number 2, Gabby, I was wondering where is the code that governs the number of deletions that's happening at the same time?
Let me find it for you. Actually, I will share my screen.
Sure.
Okay, so this is where we start. Primary log, await async work, React. This thing is being called externally. We start by creating a vector of h object called to trim, which is going to hold the object we wish to trim. And there is the max number we're going to use, which is taken from here, PG, CCT, max concurrent snap trim. That number is 2. We reserve place for 2 entries, and then we call the snap mapper get next object to trim we pass in the vector, the toTrim vector here, and we have the limit of 2. Sorry, that's the vector, and that's the snap that we wish to trim. We're going to get 2 objects here. Get next object to trim. We pass it the snap, the max, which is 2, and a vector, out vector, which is going to use. And then is iterating over the prefixes and generating 2 objects, pushing them into the out. Yes, pushing them here. But the number is really just 2. But even that, it's no big deal, because let's assume you change it and make it to be 100. Then you ask the snap mapper to give us the next object to trim, and everything went fine. There were no errors. Then we reach here. Now we iterate over the object that we got from the toTrim. The toTrim give us list of objects belonging to the snap which need to be trimmed. And then we call pgTrim object. This thing is doing the trim. There is something in the end. This is a pretty long code. You know what? Sorry. Trim object. I'm going to ignore it for now. He's going to do something on the local store. Okay, sorry. Here's the work. PG simple operation submit. This thing is done inside the loop. Do you see that this is the loop?
Yep.
The loop is done on the object inside toTrim. So for each one of them, we call trim object to manage locally all the changes, and then we generate a transaction. Transaction is done here. Okay, here's a transaction, and it's done for each object. We call issue replica operation, event replica operation, recovery state, and then replica operation put. Issue recovery operation, it's doing this. I think it's here. Simple OPC, okay. Oh, issue. Okay. Issue is calling into submit transaction. So this thing, keep in mind, this thing is called for each and every object. In the end, we call PG backend submit transaction, which eventually arrives here and which calls into update snap map. Update snap map is working on this, getting everything again, and then snap mapper update snaps. Remove object ID, just a second. Oh, okay, sorry. So update snap map is calling into snap mapper remove object ID. Remove object ID is doing this. we are still working on a single object. Again, I know it seems like a lot of code, but we're just doing the single object. Get snaps, then we clear the snaps. We clear the object ID from the snaps. We again create the object we wish to remove, and we insert we insert the snap, the object ID and the snaps. And there's something else actually we did. Maybe here, sorry, clear snaps. Yeah. So we're doing backend remove keys with the transaction. This one is doing that's the object ID. So this one is removing the object ID to snap map, and this one is removing the object ID, the snap map to object ID mapping. So there's two objects, and each one of them is calling backend remove keys, which essentially update a transaction. Is that enough? Does it make sense?
Gabby, while you were talking, I simultaneously was looking at how we kind of ended up with some of that code, I think. So I'll be honest, it doesn't totally make sense to me because I was only half paying attention, but I was also looking at this and I wanted to get your opinion on it. This was part of the erasure coding work, I think. This PR 11701 is when I believe when erasure coding was introduced.
Can you do erasure coding across PGs?
Well, the individual chunks could end up on different PGs, I believe, yes.
PG back and change update the snap map. So the number n is 2.
Yeah, I confess I'm just trying to do some archaeology to understand kind of some of the rationale here. Instead, update snap mapper and the snap trimmer to grab n at a time. That's 2? Is that right? Is that the
Yeah,
thing
the
that
number
we're?
n is set to 2. Actually, let's see if there is a number here. Where do we set the n number? It was set.
So I see there they added unsigned max equals gconf OSDPG max concurrent snap trims.
Yes, in 13128, right?
Yeah, exactly.
Where is I don't see where is this. Where did we update the max? I mean, where is this number set? OSDPG max concurrent snap trims.
That should be in the YAML.
Yeah, but I don't see
Sorry, it would have been back then. Sorry, we changed that. At the time, it would have been in the config options. Maybe it already existed because I do see in the original code there was a reference to this. So we must have already had OSDPG max concurrent snap trims. But if we,
so maybe that number exists before.
yeah, let me look and see if in that version of the source, it must be in the common options.cc. One second, and I'll find it. SCC is that what it was? This is a little ridiculous. I don't remember what it was called back then. Well, in any event, yeah, that's the setting that's being read. But okay, but then what does it mean if it says here that we're changing it to n if we were already using that somewhere, unless that was part of this erasure coding PR in general, and it was done in a previous commit in the PR. That's possible.
So I don't understand the role of erasure coding here. And since it just changed the count into 2, I don't understand what was used for this. Find the YAML file.
Sorry, yeah, it should be in the config options for in the source.
Do you know which directory it exists?
Yeah, source common options is where it should be now.
And then global YAML.
Yeah, it's in the global. It's
okay. So we have the number SDPG max and current snap strings, type
yeah.
Unsigned integer, level advanced, default 2, minimum 1, with legacy true. That's not very much. You know what I suspect? Look at this, the next one. Max streaming PGs. When you
yes.
PGs, you say, okay, don't stream more than 2 PGs at a time. That's because 2 PGs is a lot of stuff. So somebody just copy and paste the same thing.
Yeah, I was trying to find where that was introduced, where that flag was introduced.
But do you see the one below it?
Yes.
I suspect somebody copy and paste and forgot to change from 2 into 200. But still, it's not going to make any difference because, as you saw, we loop, and this thing just control how many object IDs you're going to get from the snap mapper in a single call. But once you got this vector, and let's say you got 100 entries, at the moment you just got 2, but let's say you got 100 entries, you're now going to loop over each one of them and then create a replication operation for each one of them with its own PG log entry. So there's going to be a lot of PG log entries created and then deleted. So thinking about it, I think the first change is going to make much larger impact because first it's going to impact any interaction with pglog, with Snap, not just deletion. And even for the deletion, it's going to eliminate 2 tombstone per object because at the moment when we delete an object, we are generating 4 tombstone, 1 for the object, 2 for the Snap mapper, and 1 for the pglog. By getting rid of Snap mapper or moving it away from RocksDB, it means we are down from 4 tombstone into 2 tombstones. Sorry, actually there's another impact. Every time we create a transaction, there's going to be a write-ahead log access. So by doing 100 entries at a time, we're going to eliminate the amount of write-ahead log writes. So it's going to become shorter, it's going to be, so I would say both of them are needed. And then the last change, which might be interesting, is breaking Snap mapper of a single monolithic entity describing all snaps in the system into having every PG maintain its own set of Snap mapper, and it's actually going to have in every PG going to have an hash table from Snap ID to a Snap mapper. So you're going to have I don't know, if we have 100 PGs and we got 10 snaps, 10 active snaps, then you're going to end with having 1,000 small Snap mappers, which each one of them could be accessed using its own set of locks. So when you delete a Snap mapper, you're not going to impact anybody else when you're deleting a snap. So that's the third change we suggest. I expect its impact is going to be much smaller, but it might help with reducing lock collisions. I don't know how much of this we got, how many collisions we see.
Gabby, I'm still trying to see if I can find where that was introduced, specifically that both of those options. But I haven't gotten it figured out yet. So in any event, my reading on all of this is that you should trust your gut. I think you're right that there's probably a lot here that just kind of ended up in the code base without a whole lot of thought or testing on it in terms of how fast we could do this or what the RocksDB behavior would be like. So I think especially your first proposal is a good idea. Second one, not sure about, but I think it's a very fruitful area to be looking at in general. So I think it's a good idea.
I'm still looking for feedback, mainly from Sam, because he's the guy which did big part of this code, so he should have deeper understanding of what is the reasoning for anything we did here.
Yeah, I agree. I think getting more info from Sam would be a really good idea.
Yeah.
All right. Well, just a couple minutes left here, so I'll just quickly say that I am looking at our shard op work queue in the OSD, and we talked about this a little bit last week, but the gist of it is that when you have lots of shards in one messenger thread, everything's really, really slow. And I think I figured out the reason for that this week. When we can't keep the per shard queue full, we basically let the threads just wait on the condition variable. And then if we detect that the queue is empty, but there's now something coming in, we wake everything up. We do a notify all. And I think that is the reason why this is really, really slow. When we create lots of shards and don't have enough data coming in to fill them all up, waking those threads up is really expensive. That's what it looks like is going on. So I think my guess is that anytime we get into a state like that where we don't have enough data, keep the per shard queues full, we're seeing a lot of overhead and a lot of performance degradation. If you can keep the queues full, maybe you do okay. But if you can't consistently do that, then we might start seeing performance and efficiency go down. So I'm thinking about different ways to try to change this. The one that I'm kind of focusing on right now is maybe we can have an alternate method to wake up these threads. Maybe we instead keep track of the threads that we should be waking up, and we do so individually in a loop rather than a global notify all based on
Why
that.
don't we just put them on a semaphore of such kind?
Here, let's look at the code.
Well, I think that the problem would be that you need to wake the proper thread for all of them and then check. Not just the necessary number of threads you will be interested. You need to pinpoint exact ones. But before diving further, the main question I believe will be whether it's a case we want to optimize, because it sounds that the problem happens, that the inefficiency happens when the system is already underloaded, basically.
I think, Radek, what I'm a little concerned about is that we can't essentially in a situation where the messenger threads can't keep the shards full. That's when we hit it, right? And maybe that's not common if you have a huge amount of work coming in. But I wonder, even if with our default configuration variables, how often it might be that you see those queues become empty.
Okay, this basically means that an alternative could be increasing the default number of messenger threads.
Maybe. 3 definitely is much better than 1.
Or minimizing the number of shards we have by default.
Yeah, we could both simultaneously reduce shards and increase messenger threads. But I think what I'm a little afraid of is, okay, so one question is, how good and how even is our hashing over the shards? Like, are we ever seeing situations where the clumpiness due to random distribution with the hashing means that one particular shard might be less activated than others?
Well, you mean I bet you mean sharding by selecting the shards for selecting basically TP or SDTP. The thread for selecting the shard PG will be handled by.
Yes, exactly. And
but messengers, I believe, messenger workers are far more flexible.
Yes, I agree with you on that. I guess what I'm wondering is, how often can we end up in a situation where any particular shard ends up calling notify all?
Okay.
Like, do we have cases where it's easier? Certainly, if we have fewer shards, it's a much better situation, right? Because it's much less likely that the queue becomes, any individual queue becomes empty. But then we have to increase the number of threads per shard, and that's not optimal either, it seems.
Yeah, well, how about thinking that on that next week? Well, tomorrow is day, but well, I will be open. We could talk. I need to jump into another.
Yeah, we should wrap this. we should wrap this up. But I agree with you. And then I can also show some of the locking behavior too, because I think we do see contention, especially on the shard lock. But also we see contention on the weight lock as well. So it's I think it's a balancing act a lot in this how to manage all these things.
Well, we could improve the messenger to TP passing at the price of let's say more contention around pglock and SingGuard items. Okay.
Yeah. I was even just to think about while you over the week, but perhaps maybe you have a messenger thread that well, could we work this in some ways that each messenger thread is per shard and can pull off data off the network layer? I don't know. I'm not exactly sure how that works, but things to think about how all of these different threads interact with each other in the system.
Yeah. Oh, sorry, we really need to wrap up.
Okay.
Cool. Thanks for beginning the discussion. We will get back. We'll get back to it.
Okay, sounds good. All right. I think it's probably a good time to wrap up then too. So have a good day, everyone. Thank you for coming, and we'll continue maybe that discussion next week.
Thank you. See you soon.
Bye, guys.
Bye.